Welcome to the fifth part series on Azure Basics. In this particular chapter, we'll concentrate mostly on containers. So we'll start off this course by talking about Docker and all the basics that is involved with Docker containers. We'll have a few examples and then later on we'll proceed towards all the services that is provided by Azure for Docker containers. So that includes services like App Service and Container Instance as well as Container Registry. In this particular topic, we'll not be talking about Kubernetes. So that is something that we'll talk about in the next chapter. So I hope you have a good time and I hope you learn. I'll see you in the course. Okay, so before we start talking about containers, let's talk a bit about virtual machines. So in our previous chapters, especially in our chapter one, we had created a virtual machine. So what exactly is a virtual machine? So a virtual machine is just a virtualization of a computer system. So whenever you're creating a virtual machine in Azure or any other cloud service, it's not actually a machine that is allocated for you. And on top of that, a operating system is installed. So what exactly happens is just a virtualization or an emulation of that particular computer system is made over a bare metal server. So let's look at how the infrastructure or the architecture of any cloud service would look like. So at the bottom is the infrastructure, which includes basically the hardware, things like memory, RAM, etc. Now on top of that, it's basically the most important layer, and that is the hypervisor. So the hypervisor virtualizes your physical hardware. So this is a very important thing to remember. So the hypervisor virtualizes the physical hardware. So the result is that each virtual machine contains a guest operating system as well as the virtual copy of the hardware that is created by the hypervisor, and that is required by the operating system to run the application and its associated libraries and dependencies. So here you can see an infrastructure. So this particular infrastructure could be just one server, one physical server. Now on top of that is a hypervisor. Now on top of that particular hypervisor, you can have multiple virtual machines. So it is possible for one physical server to have multiple virtual machines running on top of that. Now, the most important thing to remember is that each virtual machine has its own guest operating system. Now, these operating systems are able to run because the hypervisor virtualizes the physical hardware for each one of these virtual machines. Now, a few important things to remember is that the operating systems can be of either Linux or Windows. So it is possible for a single server on top of which is a hypervisor to run virtual machines that can either be a Linux operating system or a Microsoft Windows operating system. So that is one of the advantages of using a virtual machine. And another very important concept to remember is that these virtual machines do not recognize or know about the existence of other virtual machines within the same infrastructure. So this makes it very safe and secure. And it's much safer as compared to containers, as we'll see in the upcoming chapters. So that's it for virtual machines. Well, virtual machine is a large and huge concept to understand. And now I will share a few links that you can go through in the description below. So that will hopefully give you a better understanding of what virtual machines are. So I will see you in the next chapter. Okay, so now that we know what virtual machines are, which are basically just virtualizations and emulations of a computer system, so how is it different from a container? Containers are abstractions of the application layer that packages code and dependencies together. Now, multiple containers can run on the same machine and share the same operating system kernel with other containers. Now, each of these containers would run as its own separate and isolated process in its own user space. So you could think of these applications as small miniature operating systems which runs its own processes and which runs its own applications. Now, all these containers have one thing in common. They share resources from the host operating system below them. So in a sense, each container can be considered as a virtualization of an operating system within which your application resides and runs. So here one point to note is that your host operating system shares resources across containers. Now that is unlike your virtual machine in which resources are exclusively for that particular virtual machine and no resources are shared between virtual machines. So this makes virtual machine a little more secure as compared to containers. So that's it for this lecture. I'll see you in the next lecture where we'll talk about the differences between containers and virtual machines. So I'll see you there. So now let's look at some of the differences between virtual machines and containers. Now virtual machines are heavyweight in the sense that they require a lot more CPU, RAM, and memory as compared to containers. Now, some of the other differences include that each virtual machine runs its own operating system, whereas for containers, there is a host operating system on which your container resides. Now, virtual machines are hardware level virtualizations, whereas containers are operating system virtualization. Now, this is probably the most important differentiation between both of them. Now, the startup time for virtual machines are a few minutes, whereas containers startup time is probably a few milliseconds. For virtual machines, you have to allocate a specific fixed, whereas containers require very little memory space. And also, finally, virtual machines are fully isolated and hence are more secure, whereas containers are process level isolations and possibly less secure as compared to virtual machines. Now, these are some of the major differences between virtual machines and containers. So, in our next chapter, we'll talk about Docker. So, I'll see you there. Okay, so now let's talk about Docker. Docker is a software as a service tool that is used to create and run containers. Now, containers are miniature virtual machines within which contains applications that you want to run. And these containers run on top of a host operating system. So now let's look at all the components of Docker. Okay, so now let's talk about the architecture of Docker. Docker contains three main components. That is the Docker daemon, the Docker client, and the Docker registry. The Docker daemon is arguably the most important part among all these three. So it is in the Docker daemon that objects such as images, containers, networks, and volumes are managed. A daemon can also communicate with other daemons to manage Docker services. So all these functionalities, that is the images, containers, networks, and volumes, are something that we'll talk about in the later chapters. So the only thing you need to remember is that the Docker daemon is basically the heart of everything that happens within Docker. And one more important thing to note is that it is this particular Docker daemon that interacts with the Linux kernel to create containers and to manage these containers as well. So containers, images are topics or are subjects that we'll talk about in the upcoming chapters. And then the second important aspect of the Docker architecture is the Docker client. So the Docker client is a primary way in which you as a user can interact with Docker. So the Docker client includes commands like Docker build, Docker pull, Docker run, etc. And it's the user who would use these commands to interact with your Docker daemon. So whenever we interact with the Docker daemon, it would be through the Docker client. And then the third most important aspect of the Docker architecture is the Docker registry. A Docker registry stores your Docker images. A Docker hub is a public registry that anybody can use. And a Docker is configured to look for these images on the Docker hub by default. So you can even run your own private registry. So when you use the Docker pull or Docker run commands, these images that are being asked for are pulled directly from the Docker registry. So when you use the Docker push command, your images are pushed to that particular configured registry. So these are things that we'll talk about in the upcoming chapters. So the only thing you need to remember is that there are three main components of Docker. That is the Docker daemon, the Docker client, and the Docker registry. So that's it for this particular chapter. I'll see you in the next. So there are two objects in Docker that I would want you guys to know initially itself. That is the image and the container. So a Docker container image is a lightweight standalone executable package of software that includes everything that is needed to run an application. That is the code, the runtime, the system tool, the system libraries, and a setting. So you could consider this to be akin to a virtual machine image. The only difference is that this particular image runs on top of Docker. Now, whenever an image is run, it's called a container. So an image becomes a container at runtime. And in the case of Docker containers, image become containers when they run on a Docker engine. So that's one important thing to know. So a running image is called as a container. Okay, so I've installed Docker in my machine. So for this particular chapter, we'll pull two different images. The first image would be just an operating system, and the next image that we'll be pulling would be a web server, that is Apache web server. So the first thing we'll do is we'll go to hub.docker.com. Okay, so all that you need to do is you need to go to hub.docker.com and you can click on the explore button and you can get all the publicly available images for your application. So for example, if you want to install Ubuntu operating system on top of your Docker, you can just click on Ubuntu and you can get the official image for that. Or for example, if you want to install an HTTP web server, that is an Apache web server, you can just click on HTTPD and you can just run this particular command. So for the first example, let's get Ubuntu into our Docker. So all that you need to do is you just need to run this particular command. So the Docker pull command will pull the image from this repository into your local. So let's copy this and let's paste it in our local. So I currently have Docker installed, so you can just type Docker version and you get the relevant information. The next most important thing for you to remember is the Docker image ls. So this will give you a list of all the images that are available in your current repository. So if you click on Docker image ls currently, you will see that there isn't any. So let's run this Docker pull Ubuntu. So I'll copy this and let's paste it. and it will currently pull the Ubuntu image from our hub.docker.com. So let's wait for this to finish. And let's do a Docker image ls again. And you can see that there is an image that is there in our local repository. Now, if you're using Windows, you also get an application called Docker for Windows. Now, this is a very useful tool. So this will give you a application which will give you all the images that are currently available. So if you click on images, you can see that there is an Ubuntu image that is currently available and it's 72.78 MB. So this is basically the same thing that you see over here as well. Okay, so now that you've created your Docker image, the next thing that we'll do is we will run this particular image and create a container out of it. Now to do that, what you need to do is you need to run the docker run command. And for this particular instance, I will run it as an interactive terminal. And all that I need to give is just the name of my particular image, which is Ubuntu. And you can also give a tag if you wish. So the tag that we have is latest. So if there are other tags, you can give that as well. So let's run this particular image. And now you can see that I have entered the terminal for this particular container. Now, if you go back to your Docker in Windows, you can click on your container and you can see that there is a running instance of this particular image. And if you go back to your image, you can see that this is the particular image. So this particular image is being run as a container, which is this. And within this particular terminal, you can run commands like who am I, pwd, etc. So these are Linux commands that you're running within that particular Ubuntu container. So that is it for this lecture. In this lecture, you saw on how you can pull an image from a Docker Hub and create a container out of it. And once you've created a container, how you can interact with that particular container. So in the next lecture, we'll see on how we can create a Apache web server using the same method. So I'll see you there. Okay, so in our previous chapter, we were able to create a container out of an Ubuntu image. In this particular chapter, we'll do something different. We will create an application, Apache web server, and then we will deploy it in a container. So the first thing you need to do is you need to pull the appropriate image. So we have the HTTPD official image. So what we'll do is we'll pull this particular image. So I'll just copy this command and I'll go to my prompt and let's exit out of, and let's run this particular command. Okay, now let's do an Docker image ls. So you can see that we were able to get the HTTPD image in our local repo. So all that we need to do is we need to run it. So now the difference between our previous example and this example is that in our previous example, we just wanted to interact with our Ubuntu operating system. Now this is going to be a little different. So in this particular example, we need to interact with our web server using our web browser. So what we need to do is we need to connect the port of our container with the port of the host operating system, which in our case is Windows. So the diagram would look something like this. So we have a container and the container has Apache running on it. And this particular Apache web server would run on port 80. And this particular port 80, we will expose to port 8080 of our operating system, the host operating system. So what we need to do is we just need to do a localhost 8080 to interact with this particular Apache web server. So let's do that. So all that we need to do again is just run the docker run command. So let's run the docker run command. And here I need to map the ports. So what I'll do is I'll map the port 8080 of my local operating system to port 80 of my container. And all that I need to give just the name of my particular image. So that would be HTTPD. And if you wish, you can also give the tag as latest. And let's run this particular command. So this should be HTTPD. And you can ignore this particular warning for the time being. So let's go back to our browser and let's see if you're able to connect. So let's do a local host. And it should be port 8080. And let's run this. And you can see that you get an output like this. So all that means is that the Apache web service is working. So you can also go back to your Docker for Windows and you can click on containers and you can see that it's running currently on port 8080. And you can also click on this particular icon, which will open it in a browser as well. So just click on this and you can see that it gives the same output. So that is it for this lecture. In this lecture, you learned how you can create an Apache web server and host it on a container and expose its particular port to the host operating system. So I will see you in the next chapter. Okay, in this particular chapter, we'll talk about uploading your images to your own private repository. So whenever you create your account in hub.docker.com, you have the opportunity of downloading your images within your own private repository. So to do that, the first thing that we need to do is we need to create a tag for a particular image, and then we need to upload it. So let's go back and let's see how this is done. So let's exit out of this. So first thing is let's do a Docker image ls. And currently you can see that there are two repositories. Now the name of my particular private repository is this. So I need to create a tag with this particular name provided by the name of my particular image. So let's do that. So to create a tag, all that you need to do is just run the docker tag command. And then I need to give the source name, which is basically Ubuntu, and the destination tag name, which is the path of my private repository. And I will also call this Ubuntu as well. And you can also give a tag called latest, or it could be anything else as well. So let's call this as version 1. And let's run this particular command. Okay, so, and let's do a Docker image ls once more. And you can see that it got created as this. So the tag here is version 1. So all that I need to do is I just need to push this particular repository now. So to do that, let's just run the docker push command. Now, of course, I need to be logged in as well. So let's do a docker login. Okay, so I had already previously done the authentication, so that's why it's just authenticating with the existing credentials. So if you're authenticating it for the first time, you'll just need to give the username and password. So now all that I need to do is just give a docker push command, and I just need to give this particular name. And the version is version 1. So let's run this particular command. So it's going to push it to this particular repository. So this is my private repository, and this is going to be the name of my particular image within my private repository. So let's wait for this to be pushed. And once your push is done, you can go back to your UI again. You can go to your Docker Hub and click on repositories here. And you can see that your Ubuntu repository is available. So all that we need to do is we need to just pull it from this particular repository. Now, again, to do that, let's go back to a console. All that you need to do is just do a Docker pull. And this time you need to pull it from your own repository. So instead of just giving Ubuntu, you need to give this as Ubuntu. And let's click on enter. Now the reason why it failed here is it's expecting a default tag as latest, but what we put is version 1, as you can see over here. So all that you need to do is you just need to run this command, and you also need to put the version as version 1. And let's run this again. So you can see that it has been pulled to your particular account. So let's do a docker image ls. So as you can see that this particular image was already there. So let's remove this particular docker image and let's do a pull after that. So to remove your image, you can just do a docker image rm and here you need to give the name. So I'll just copy this, paste it here. You need to mention the version as well. And let's do a docker image ls now. And you can see it's not there. So let's do a docker image pull again. So again, I'm going to pull the docker image from this particular version. Let's run this again. And let's do a docker image ls. And there you can see it's currently available for use in your local machine. So that's it for this lecture. In this lecture, you've learned how you can use your remote repository to store images. So I hope this was a useful lecture. I will see you in the next. Okay, in this particular chapter, we'll talk about something very important, that is creating our own image. So in the previous chapter, we had pulled an image from the Docker Hub, and we had used that particular image to run our container. In this particular instance, what we'll do is we'll create our own image and then we will run that as a container. So let's see how we can do that. So the first thing that we need is an application. So in our example, we'll be using a Node.js application to do that. So this is the application that we want to run within our particular container. It's just a very basic Express application, and it just returns a hello world back to the user and nothing more than that. And it will run on port 80 and it will run on localhost. So what we have is just a very basic server.json and package.json file. So we will create an image for this particular application that will run this particular Express application. So to do that, what we need to do is we need to create something called as a Docker file. So let's do that. So I will click on new file and I'll create my first Docker file. And let's open our Docker file. So the first thing that the Docker file must contain is a base image. So it's on top of that particular base image that we will create our own image. So for our example, what we'll use is basically a node image, and it is going to have a tag called slim. So let's check out what this particular image is. So I go back to my Docker Hub, and in my Docker Hub, I will search for node, and I get the official node image. And within this particular node image also, I will choose a very specific tag. So if I go to my tags and if I choose the latest, so if you look at the latest, you can see that it has a massive size of around 332 MB. We do not want a very large base image. So instead of using the latest, we'll use something called as slim. And this particular slim tag for our node app, for our node base image has just a size of 60.72 MB. And this particular slim tag is good enough for us to create an Express application. So we'll be using this particular tag. Okay, so now that you've set your base image, the next thing that we need to do is we need to create a work directory. And this work directory by convention has this particular path, that is user source app. I mean, you can have any other path you want. So it's basically just up to you. So this particular work directory becomes our current present working directory. So that's one thing you need to remember. Now, if you need to have more information about work directory, you can go to the official Docker file reference, and this particular Docker file reference will have all the information relevant to your work directory. So the work directory instruction sets the working directory for any run command, entry point copy, or any add instructions that you want to follow in your Docker file. So if the work directory doesn't exist, it will be created even on its own. So it's not mandatory that you need to create your own work directory. So once your Docker file is created, if that particular work directory is not there, it will set on its own. Okay, so once you've created your work directory, let's go back to our Docker file. So the next thing that I need to do is I need to transfer my package JSON to my work directory. So to do that, I just need to run the copy command. So I'll run the copy command and I need to just copy the package.json file, which is basically my source, to my work directory. And this particular command does it. And once I've copied it, okay, let me just, and once I've copied my package.json, I need to run the run command. So this run command will execute my particular package.json file. So all that I need to do is I need to run npm install. Now, one thing to remember is that because I have my node as the base image, so it will automatically have my npm installed, pre-installed. So that's something I do not need to worry about. And once I've done that, the next thing that I need to do is I need to copy my server.js file as well. So let's do that as well. So I'll again do a copy server.js, and I will copy it again to my work directory, that is user source app. And after this, all that you need to do is you just need to expose port 80. And it's on port 80 that your application would be running. And after that, finally, you can just run the command. And within this command, you need to have the executable as well as the parameters. So what we'll execute here is node, and the parameter would be server.js. And that's it. Our Docker file is ready to go. So now all that I need to do is I need to build an image out of this particular Docker file. Now to do that, let's open a terminal. And all that I need to do is I just need to run the Docker build, and I need to give a name for my particular. So let's tag this particular application as well. So let's call this as node app, and it's going to be the latest version as a tag. And that's it. And I just need to give the dot path. So this is the path to my Docker file. And let's run this particular command. Okay, so our Docker build command is done. So let's do a Docker image ls. And here you can see that our image is created. So now let's run this particular image. So all that this particular image will do is return a hello world back to the user. So let's run this. So again, this time what we'll do is we'll run it using the application that we have. That is this particular Docker on Windows application. So let's go back to our images. So it's in our local. And this is our particular image that we just created. So let's just run this. So let's click on run. And here let's set the optional parameters as well. So here the container port is port 80, and let's make the local OS port as 80 as well. So it's going to listen on port 80, and let's run this particular application. And once you've done that, all that you need to do is you just need to go to your containers. And here you can see that this particular application is running. So all that I need to do is I just need to open it on a browser. So let's click on this particular open in browser. And you can see that my hello world works here. So that's how you can create your Docker image and run it as a container. So the next thing that we'll do is we'll open our particular container. So let's open it in a CLI and let's see what's there in the work directory. So let's do a pwd. So now I'm currently in my work directory, and here you can see all the relevant files that were moved from your local to your container. So this is the package.json that was moved, and this is the server.js that was moved. And this node modules was created when we did an npm install in our work directory. And finally, to see your running process, you can run this particular command. So this particular command I got from this particular Stack Overflow page, and this particular page I will give in the description below. So this particular command returns this output, and you can see that our node application is currently running within this particular container. So that's it for this lecture. I hope this was a useful lecture for you. Lecture you learned how using the Docker build command you can create your own image and use them as a container. So I will see you in the next chapter. So in this particular chapter, we'll talk about how you can persist data in your container. So the data that you store in your container is only valid as long as your container exists. So as your container exits or is shut down, then that particular data that you have stored is no longer accessible to anybody. So to overcome this situation, you can either store your data as volume or as a bind mount. And if you're using Linux, you also have the option of storing it as temporary mount within your memory. But again, this is only valid as long as your container exists. So if your container goes down, then your temporary mount also goes down. So the best way to do it is using volumes. So if you're using volumes, then your data is stored within a Docker area in your file system within your host operating system. So this particular area is only accessible to Docker containers, and no other application or process can access this particular Docker area. Whereas if you're using bind mount, the data that you store can be used by other non-Docker processes as well. So the best way to store your data is to use volumes and not to use bind mount. So let's start our next chapter by creating a volume, and let's see how it works. Okay, so now to explain how volumes work, I'll be using a Cloud Shell environment. Now you can use any Linux environment and it should work fine as long as Docker is installed in it. So let's see if Docker is installed in my particular Cloud Shell environment. You can see it is. So the first thing I'll do is I will create a volume. So to create a volume, all that you need to run is the Docker volume create, and you need to give a name for your volume. So I'll just call this as my volume. And you can see that my volume has been created. Now to get more information about your volume, you can just do a Docker volume inspect, and you just need to give the name of your volume. So the name of my volume is my volume. And you can see that the mount point is this in our host operating system. So if I go to this path, it'll give an access denied. So let's copy this and let's paste it. So you can, however, use your sudo to access that particular path. So let's do that cd again. And you can see that currently this particular directory is empty. So let's exit from our sudo. Okay, so now that you've created your volume, the next thing that we'll do is we'll create a container out of the Nginx image that we have. And we'll be using the volume that we've just previously created. So this particular volume will be mounted on /app within our container. And after we've done that, we'll just run the bash command. So let's run this particular command. And currently we are connected to the container and we're using the bash shell. So what we'll do is we'll go to the cd app and let's add a particular file to this particular path. So I'll just do a touch ABC. And once I've done that, let's just exit out of our container. And currently I'm back in my host OS again. So again, let's do a Docker volume inspect for my volume. And let's go to this path again. So this particular path, which is in a host directory, should contain the file that we just created. Again, we need to do a sudo su. And let's go to this particular path. And you can see that this particular file that we had created within our container is accessible in this particular path. So that is how your volume works. So your volume data will be available to any container that is attached to this particular my volume. So that is it for this lecture. In our next lecture, we'll see how the bind mount works. So I'll see you in the next chapter. Okay, so now let's talk about bind mounts, which have been around since the early days of Docker. So when you use a bind mount, a file or a directory on the host machine is mounted into a container. So the file or directory is referenced by its absolute path on the host machine. By contrast, when you use a volume, a new directory is created within your Docker storage directory on the host machine, and Docker manages the directory's contents. However, that is not the case when you're using a bind mount. So the problem with bind mount is that it can also be accessed by other non-Docker based processes as well. It is less secure when compared to volumes, and volumes are generally preferred over bind mount. So let's see how we can create a bind mount. So let's go and look at this particular documentation. Now, this particular URL I will send in the description below, so you can just check that out. So if you go and look at this particular diagram, you can see that whenever you're creating a volume, the volume is created within a Docker area, and this Docker area is a protected environment and it can only be accessed by a super admin, whereas the bind mount can be accessed by anybody and it's within the general file system. So let's create our first bind mount. So all that you need to do is you just need to run this particular command. And again, it's a Docker run command, and we'll be creating a container from this particular Nginx image. And the important arguments that you need to know here is that this particular argument mount and it's of type bind, and the source here is the present working directory in our source operating system followed by a /target. So this particular path should be present in your source operating system. So you must always remember to create a target folder, and then the output is basically the /app within your container. So it's within this particular folder that your data will persist in the container. So let's copy this. Okay, so first thing that we need to do is we need to create a target absolute path for a particular bind mount. So let's do that. So we had chosen our present working directory, and then to we have to create a folder called target. And it's within this particular folder, that is the target folder, that our bind mount will be created. So okay, so once you've created the folder, let's run that particular command that we had previously seen. So this is that command. So again, it's going to be a Docker run that will create a container out of this particular image. And then again, the mount is of type bind. And the source here is the absolute path that is presented as source operating system. That is the present working directory that points to this. And then a target folder. And it will be mounted on this particular /app in our container. So let's run this particular app command. And okay, so I'm in my bash within my container. So let's go to the /app folder and let's create a few files here. And let's exit out of our container. Okay, so once we exited, let's go to the target folder that we had created. So let's do a cd target. And if I do an ls, you can see that these two files are present here as well. So we have mounted this particular folder on our container. So let's also create another container, and let's use, instead of using nginx, let's use an ubuntu image. So we'll run the same command again, and of course the source again would be the same, and the target would be again slash app within this particular ubuntu container that we'll create. And let's run this once more. Okay, so I need to go to my present working directory, and let's run this. So the problem here was I was in the target directory, and within this target directory is expecting this particular path which isn't there. So I have to go back to my previous path and run the same command again. So let's run this again. Okay, so there is a container by that name. So let's call this as, okay, so we are in our Ubuntu container now. And let's go to a slash app and let's see if we are able to access these two files. So if I do an ls, you can see that these two files are present even in my Ubuntu container that I created. So this data does persist, and you can create other containers, and those containers can access this data as well. And let's create a file within our Ubuntu container as well. So let's do a touch abh, and let's exit out of this, and let's go to our target folder, and let's do an ls, and you can see that this abh is present here as well. Okay, so that's it for this lecture, and always remember that volumes should be the preferred way of persisting data in Docker and not your bind mount. So I will see you in the next chapter. So apart from volumes and bind mounts, if you're using Docker on Linux, you have a third option of storing files, which is outside the container's writable area, and that is called as the temporary file system. So let's look at this diagram. So when you create a temporary file system mount, you're creating data that resides within the memory of the host file system. The limitation of using temporary file system is that you cannot share your temporary file system mount with other containers, and this functionality is only available if you're using Docker on Linux. And the third disadvantage is that this particular data is not persistent. So as long as your container is up, your particular container can access that data. So if your container goes down or if it's removed, that data also disappears along with that particular container. So let's create a temporary file system mount. So again, the command is literally the same. The only difference here is that the type you have to give is the temporary file system, and you only need to give the destination. So you do not need to give the source within your host operating system. So let's run this particular command. So I just copy this. And now let's run this docker run command. So here I'll give a new name for my Docker. So let's just call this temp container. So again, everything remains the same. The only difference here is that the mount type is temporary file system and the destination is slash app. And once I run this command, I will open the bash shell. So let's run this. So currently I'm in my bash shell. So let's see if there's a slash app path present. And you can see that there is. And within this particular path, you can store any file that you like. And this particular file or anything that exists within this folder will only persist as long as your container is running. So that's it for this lecture. I will see you in the next. Okay, so now let's talk about networking. So previously we had talked about containers, images, and volumes, and this is going to be the final topic on Docker, and it is networking. So networking is a very basic concept to understand. So you have multiple containers within the same host, and you want these containers to communicate with each other. So networking makes it possible for containers to communicate with each other. So in this particular exercise, we'll talk about the two very basic networking patterns that is followed in Docker. That is the host and the bridge network. So let's start our next chapter by talking about the bridge network. I'll see you there. So now let's talk about the default network that is available in Docker, and that is called as the bridge network. So in Docker, a bridge network is basically a software bridge which allows containers connected to the same bridge to communicate with each other while providing isolation for containers which are not connected to the bridge network. So the Docker bridge directly installs rules in the host machine so that containers on different bridge cannot communicate directly with each other. So let's start off by creating our first bridge network. Now, of course, one thing to remember is that whenever you create a container, it automatically goes to a default bridge. So you have the option of creating a new bridge network and inserting your containers within that new network. So let's do that. So let's go to a console. So I'm back in my console. So the first thing I'll do is I'll check all the networks that are currently available. So that for that you can run the Docker network ls, and you can see that these are the networks that are currently available. And this second one is basically the default network that is available to you. And whenever you create a container, and if you do not specify any network, then it automatically goes to this particular network. Okay, so for our example, we'll create a new network. So let's create a new network. And let's call this as my new network. And let's do a Docker network ls again. And you can see that this particular network got created. So the next thing that we'll do is we'll create a container and we'll specifically mention that particular container should belong to this particular network. So let's do that. Okay, so now that you've created your network, let's create a few containers. So I'll create a container out of my Ubuntu image. So let's do a Docker run and I'll open it in the interactive mode and I will specify the network. And the network here would be my new network and the name of my image. And let's open the bash shell. So let's run this particular command. Okay, so I have created one particular container. So let's create another container. So let's open another command prompt. And let's run the same command again. I need to specify the network, which is my new network, the name of my image, and the bash shell. Okay, Okay, now that we've created these two containers, let's try to ping each of these containers. But before that, we need to know what is the IP address of both these two containers. So let's open another prompt. So what I need to do is I need to run the Docker network inspect my new network, which is the network that we've created. And if you open this, you will get a JSON file, and the JSON file has got a key called containers. And within this containers, you get all the information that you need. So the IP address is 179.19.03 and 179.19.0. So what we'll do is we'll try to ping these containers. So let's run the ping command. And you can see that the ping command is not there. So what we need to do is we need to install the ping command. So let's do that. So to install the ping command, what you need to do is you need to run your app get update. So let's copy this, let's run it. And similarly, you also need to install this particular library as well. So let's get this done. Let's do it for the other container as well. Okay, so I've installed ping in both the machines, so we can just do a ping just to verify. And yeah, so the ping is installed. So all that we need to do now is we need to find the corresponding IP addresses for these containers. So this corresponds to the container ID and this corresponds to the container ID of the other container. So let's open the command prompt once more and let's run the container uh, docker container ls, and this 898090 corresponds to this particular container, and similarly 21412 corresponds to this. So again, let's run the docker network my new net inspect. And here you can see that unruffled Shirley has this particular 214.1.2 has this particular IP address. So what we'll do is from unruffled Shirley, we'll try to ping this particular machine. So what I'll do is I just copy this particular IP address and let's ping the other machine. And you can see that the ping worked and it was able to send a ping request to the other machine. So in this way, you know that these two containers are connected with each other. So that's it for this lecture. I hope this was useful. So one last thing we will do is we'll just exit out of this. I'll create another container and that container will not be connected to this network, but it will be connected to another network that is the default network. And let's see using that particular container whether we are able to connect to these containers that are within another network. So the first thing we'll do is we'll create a container again, docker run, and this time I'll not specify any network. So I'll just run it in the iterative mode and let's run it with bash. And let's try to ping this particular machine. So let's do a ping 172.19.02. Okay, so we need to install ping. So let's do the installation of ping once. Okay, so I installed the ping command. So let's try to ping the other network, that is the my new network from our default network. And you can see that it doesn't work because it's not within the same network. So once again, let's exit out of this and let's run the docker inspect network for my new network. And you can still see that this particular inspect for that network has just two containers. So the other container, that is the one that we recently created, is not present in this particular network, but is present in the default network. And we can verify that as well. So instead of inspecting my new network, let's inspect bridge. So you can see that the bridge network has this particular container. So I hope this was a useful lecture. In this lecture, you've learned how to create a new bridge network and add containers to it. So I hope this was useful. I will see you in the next. Okay, so now that you know a bit about Docker, let's go back to our Azure services. And the first service that we'll take care of is the container registry. And the container registry is just like your Docker registry, and it's just used to store your images. So let's click on container registry. You can either search for your container registry on the search bar, or you can go to your all services and you can find your container registry within your containers tab. So let's open a container registry. So the first thing that you need to do is you need to create a new registry. So just click on create and you can place it in any resource group. And let's give a name for our registry. So I'll call this as VLC and let it be a standard container registry. So let's click on review and create. And let's click on create. Okay, so our registry has been created. So let's click on go to resource. And what we can do here is we can upload our container images within this repository. So let's click on repositories here. And here at this moment, because we haven't created any repository, so what we'll do is we'll create a registry. So the easiest way to get this done is you can go to click on quick start and you can get all the relevant commands that you want. So what we need to do is we need to create our image in a local machine. And then once we've done that, we just need to Docker log into our Azure registry, that is the container registry. And then we just need to push our particular image. So let's do that. So let's go back to our Azure Visual Studio Code. So what we'll do is we have this application. So the first thing that we need to do is we need to create an image in our local machine. So let's do that. So this is a very simple Express application which just has a server.js. and a package.json file. The first thing, again, like I said, is we just need to build an image from this particular piece of code. So let's do that. To do that, all that you need to run is the docker build command. And let's give a tag of express app, and let's just give this current path. And let's create an image out of this in our local. Okay, so once you've created the image, let's log into our Azure Container Registry. So to do that, I just need to copy this. Let's paste this. And it'll ask for a username and password. Now to get the username and password, you again go back to your console and you just need to click on access keys. And here, let's just enable this admin user. And let's copy the username and password. So this is the username. And similarly, the password as well. I'll copy this. Okay, our login is successful. Now let's do a Docker image ls. And now let's tag our image. So I'll do a Docker tag, and our image is express app. And we need to tag it as, I'll just copy this path. And the name of our repository in our container registry would be express app as well. Now you can also mention a tag. However, if the tag is not mentioned, it will automatically pick it up as latest. So let's run this Docker tag. And now let's do a Docker image ls once more. So you can see that the tag is latest, and this is our repository. And now all that we need to do is we just need to do a Docker push. Okay, so our repository has been pushed. Now let's go back to our container registry and see whether it's available. So I'm back in my container registry. Let's go to the repository. And you can see that our Express application repository has been pushed. And it has one particular tag, that is the latest tag. Okay, so that's it for this lecture. In our upcoming chapters, we'll be using this particular image to create containers. So I will see you there. Okay, so now that you've stored your image in your container registry, let's make use of that container registry to create a container. So to do that, you need to go to your container instance. Now, of course, you can search for your container instance in the search bar. You can find it here, or you can go to your all resources, and within your containers, you can find your container instance. So let's click on this. And here, let's create a container instance. So I'll click on create. And here, let's create a first container instance. So we can just put it in any resource group. So let's put it in a resource group, or let's create a new one. Click on OK. Let's give a name for our container instance. And here you have the option of either choosing a quick start image, or from a Azure Container Registry, or from a private or a public Docker Hub registry. So let's start by using the quick start image for this particular chapter. In the next chapter, we'll do the Azure Container Registry, and then after that, we'll use the Docker Hub. So let's click on review and create. And here you can also choose the size. So let's choose the most minimum CPU and memory. So let's click on OK. So this seems fine. And let's click on review and create. So we passed the validation. So let's click on create. Okay, so our resource has been created. Let's go to that particular resource. And let's click on containers here. And you can see that a container has been created and it's pointing to this particular image that is the hello world latest. So let's open it in our browser and let's see what we see here. Let's copy this and let's paste it. And you can see a default welcome to Azure Container Instance. So that is it for this lecture. So this lecture was not very useful. So you're just pulling a basic Microsoft image and making a container out of it. So in the next lecture, we'll see how we can use a container registry and pull an image from our container registry. So I'll see you in the next chapter. Okay, so in this particular chapter, we'll again create a container instance, but this time we'll be using the image that we had put in our container registry in the previous section. So let's do that. So again, I'll be using the containers resource group that I had previously created. And let's call this my container registry. And this time we'll be using the Azure Container Registry. So we had created an Azure Container Registry by this name, and it has an image called Express App. And there's only one tag that is the latest tag. So let's create this particular container using the image that we had previously created. So let's click on Review and Create. So everything is very straightforward. So all that you need to do is click on Create. Okay, so our deployment is create. Okay, so our deployment is done. So let's go to the resource. And all that we need to do in our application now is to just copy the IP address and let's paste it somewhere. And here you can see the hello world. So this is basically just the Express application that is running in that container. So I hope this was a useful lecture. In the next lecture, we'll see how you can use your Docker repository, both public as well as private, to create your container. So I'll see you there. Okay, so now let's finish off this section by creating an instance using our Docker public repository. So let's click on create. And we'll create this within the containers resource group. And let's create an Nginx web application using our container. So let's just call this as Nginx web app. And let's make this in US East. And here the only difference is that I just need to click on this Docker Hub. And I can either give a public image or a private image. So let's give the most commonly used Nginx. And let's use the latest tag for Nginx. And that's all that you need to do. Everything else remains the same. So let's click on Review and Create. And let's click on Create. Okay, so a resource has been created. So let's go to the resource. And let's open this public URL. So I'll copy this and let's see if we can. And you can see that we can see the Nginx page. So that is how you can use your public repository. So let's go back to our application once more. And we'll create one final container instance. So let's click on container instance once again. Let's click on create. And we'll create this within the containers resource group as well. And here the only difference is that I'll click on Docker Hub and let's use the Docker Hub private repository to fetch our image. So what I'll do is I will go to my Docker Hub. I'll just copy this URL. So the name of my particular image is this. I'll copy this. I'll paste it over here. And if you look at the tag mentioned here is version 1. So I'll copy this. I'll paste it over here. And let's give the username and password as well. And the password is this. So everything seems fine. So let's click on review and create. Okay, I need to give a name for my And let's click on create now. And let's go to our resource. Let's click on containers. And here you can see that your particular container instance got created. So now this particular instance is not connected to any web server. So it will just exit after it has been created. So that is it for this chapter. So in this chapter, you learned how you can connect both to your public Docker as well as to your private Docker account. So I hope this was useful. I will see you in the next chapter. Okay, so in our previous chapter, we've learned how you can deploy one particular container into your container instance. In this particular chapter, we learn on how you can install multiple containers into your container instance. So let's see how this can be done. So now to install multiple containers into your container instance, there are three ways in which you can do it. You can either create a container group using a YAML file, or you can use a resource manager or a Docker Compose. So a Docker Compose is something that I'd explained to you previously. So let's not go into that. And the resource manager is something that I'll explain to you while I talk about infrastructure as a code. So for the time being, let's see on how you can deploy your multi-container instance group. So let's click on this. So all that you need to do is you need to configure a YAML file, and the YAML file looks something like this. So it has these properties, the API version, the location, the name, as well as all the properties related to the container. So here in this particular example, you can see that there are two containers that have been deployed. So what we'll do is we'll copy this and we will use it in deploying our images that we already have. So let's copy this and let's go to VS Code and let's paste this particular application. And let's paste this YAML code. And what I will do here is I will install two web servers. So the first thing I'll do is I let the location be East US, and here I need to give the name for my instance, container instance. So let's call this as my web server. And let's install two containers in this. So the first would be a Nginx, and I'll just give this as Nginx and we'll pick it up from Docker. And this I will just map it to port 80. And similarly, I'll also have one more. I'll copy this and I'll paste it here. So I'll just call this as HTTPD and it'll pick up the Apache Web Server application image. And this would be read on port 8080. And the only other thing I need to do is I need to go to ports and I need to map both these ports here as well. So this represents your Nginx and this represents your HTTPD. So let's run this application and let's see whether it works. So I'll go to my terminal and let's run this particular application. Now to run this application, you just need to run the Azure Container Create. And here you need to give a resource group. So the resource group I've given is containers. And I also need to mention the location of this YAML file, which is multi.yaml. So let's run this. Now let's go back to our console and let's see whether it has worked. So I'll go to my container instance. So there's a my web server that gets created. And you can see that there are two containers. And let's go and click on containers. So now you can see one of these containers failed. Now the reason for that is if I go back to my YAML file, you can see that there is no port mapping allowed. So my particular HTTP application, even though it's reading from port 8080, the image from which I am reading this particular application expects the user to communicate via port 80. So there is no port mapping that can be done from port 8080 to 80. So this is a very common concept in Docker where you map ports together. Now, because of that reason, your particular configuration here fails. So what I need to do is I need to create an image and that particular image should be reading from port 8080. And that is precisely what I have done. So I have gone and created a new Docker image. So let me show you that particular Docker image. So it's a basic node application, and this particular node application would be reading from port 8080 and not port 80. And I'll be using the image that I've created of this particular application to run our container instance. So let's go back to our previous file. And here what I will do is I will just change this from HTTPD and I'll call this as a node application. And let's fetch that particular image that I had created. So I'll go back to my, so let me open my Docker Hub account. So this is the application that I have created, and this particular application has port 8080 open. So I'll be using this particular application. So let me just copy this. And this has the tag of latest, so I do not need to change that. And here, instead of HTTPD, I'll just paste this image. So now this particular Express application has port 8080 opened, and that port 8080 will connect to this port 8080, and I can communicate to this application via port 8080, and it should work fine. So let's go back to our web server, and let's remove this application. Click on yes. And now let's run our YAML file again. So again, it's Azure Container Create. It's the same resource group and the same YAML file. And the only difference here is I'm using another image, and this image has port 8080 open. So let's run this application now. Okay, so now hopefully my containers, both of them should work. So let's go back to our console now and let's refresh this. And let's open our web server. And here now, if I go to the containers, you can see that both of them are in a running state and none of them are in terminated state. So let's click on overview and let's see if we can access both those applications. So I'll copy this and let's paste it. So this is the Nginx, which is running on port 80. And if I go to port 8080, you can see that my node application is running, which just displays hello world. So that is how you can run multiple containers in your container instance. So the only thing to remember is that your port mapping does not work in the YAML configuration. So you need to manually configure it in your Docker before you use it in your container instance. So I hope this was useful. I will see you in the next. Another way of creating multiple instances in your container instance is using the Docker Compose file. So this is how the Docker Compose YAML file looks like. So it has the version, and here you need to mention the services, and here each service represents a container image. So here I have two services. The first is the Nginx, and for the Nginx, I will give the container name as Nginx container. And this is the path of the image. So image would be just the Nginx image that I'll pull from Docker. And the second image is the node application. And this node application I will pull from my container registry in which I have uploaded this particular image. So this is the same image that I had used in my previous chapter. And this particular image opens port 8080. And this port 8080 is open to port 8080 of our container instance. Now, one thing to note is that you cannot do a port mapping in container instance. So you cannot map port 8080 to any other port. So this has to be the same. So that is one thing, and that is probably one of the biggest disadvantages of using container instance. That is, you cannot do any port mapping. So this is how our Docker Compose file looks like. So let's use this Docker Compose file to create a container instance and to push these two images into a container instance. So let's do that. So one thing to note here is that this thing works only using CLI. You cannot do this using the console. So first thing I'll do is I'll just do an AZ login. And let's log in using my account. Okay, so I've logged in to my account now. So let's clear this. So the next thing I need to do is I need to create a context. Now to get more information about context, I will send you a link in the description below so you can just check that out. So let's create a context. So to create a context, you need to run the Docker context create ACI, and you can give a name for your context. And here you need to choose in which particular resource group you want your particular project to be in. So let's put it in our containers project, which is in Central India. So let's choose this. And we've created a context. So let's do a Docker context ls. And these are all the contexts that are currently available. So currently it's this context that I'm currently pointing to. So let's move it to this particular context that I've just created. So to do that, let's use the Docker context use and I will use this new context that I just created. Okay, so okay. Okay, so now that you've created your context, all that you need to do is you just need to run the docker compose up command. Now, you can also run this locally, but it'll do the same thing. So there isn't much complexity involved in this. So let's just do a docker compose up and create a container instance and push these two images into that particular container instance. Let's click on enter. And currently it will create a new container instance and it will upload all these two containers into it. So let's wait for this process to finish. Okay, so our process is done. So let's go back to our console and let's refresh this. And you can see that our container app got created. So let's open this. And within this, you click on containers and you can see that there are three containers. Now, these two are containers that we had uploaded. And this is one of the containers that Microsoft uploads for monitoring and configuration. So let's use and check whether the other two containers that we have created work. So let's click on overview. So one of them, the Nginx is on port 80 and the other one is on port 8080. So let's click on overview and let's copy this and let's paste it. And you can see that port 80 points to Nginx and port 8080 points to the node application. So that is it for this lecture. So in this lecture, you learned how you can use Docker Compose to create multiple containers in your container instance. So I hope this was useful. I will see you in the next. Okay, so in this particular chapter, we'll be creating a CI/CD pipeline for our application. So the first thing that I need to do is I need to create a project in my GitHub, and then I will build that particular image and store it in my container registry. And once that is done, I will push the code from the container registry to my container instance. So all of this should happen seamlessly. So let's see how this is done. So the first thing that I'll do is I'll go to my GitHub and here I will store my application. So I've created a repository and this repository has just the server.js as well as the package.json and the Docker file. So the first thing that I need to do is I need to move this to our container registry. So let's do that. So what I need to do is I need to open my Azure DevOps and I have created a project. So let's open this project. And what I'll do is I'll go to my pipelines, click on pipelines, and I'll create a new pipeline. So let's click on new pipeline. And here I need to choose GitHub. So let's click on GitHub here. And this is the repository that I've created, which contains my code. So let's click on this. And here I need to give permissions. So click on approve and install. So here you need to configure your pipeline. So the first thing that I will do is I will build and push an image to my Azure Container Registry. So let's click on this option. And here you need to choose your subscription. So let's choose the subscription that we have and click on continue. And here you need to log in. So let's log in with the user that I have. So let's click on next. Click on sign in. And here I have a container registry. So within this container registry, my repository will be stored. So let's click on this and click on validate and configure. And the first thing that we will do is we will store this in our repository. So all that I will do is I will just click on save and run. And This will set up a CI/CD with Azure pipeline. So let's click on save and run. And let us wait for a repository within the container registry to be created. So let's wait for this to be over. So let's go back to the container registry, and within this container registry, there should be a repository that should be created. So let's refresh this and let's wait for that build to be over. And you can see that it has succeeded. So let's go back to our registry and let's refresh. And you can see that a repository got created. So let's open this. And there is a build that got created. Okay, so now let's add another task to this particular pipeline. So let's go back to our pipeline. And this time what I'll do is, okay, so now let's go back to our pipeline. So we'll add one more task to our particular pipeline. And this particular task will deploy our application in our container instance. So let's edit this particular pipeline that we've created. And what I need to do is I need to add a task. So unfortunately, there is no direct task to deploy a particular image to our container instance. So what I need to use is basically the Azure CLI. So let's do that. So first thing you need to do is you need to make sure that your cursor is pointing at the right place. So it has to point to the end and it should point at the exact line where your task is. So let's add the Azure CLI and let's use the subscription that we have. And we'll be using the shell command. And the script location would be just an inline script that I'll add. And here I need to add the appropriate Azure CLI. So let's look for the Azure CLI to create a container instance. So I'll be using this particular command to do that. So let's just copy this and let's update it. So here I already have a sample of that particular command. Here I'll change the name and here I need to give the login server. The build ID will be automatically populated. And again, the login server, the container registry name and the password. And again, the DNS name symbol. So this is a unique name that should be there. So these are the appropriate values. Now to get more information about this particular command, I will send a link in the description below. So that particular link will help you out. So all that you need to give as a variable is the resource group, the container registry login server, as well as the container registry login name and the password. Now to get that information, let's go back to our cloud registry once. And within this registry, you can click on your access keys. And here you find the username, the password, as well as the server. So you can get all these three information from here. And the resource group in which you're going to put that particular resource would be just any of the resource groups that are currently available. So I will put it in the containers resource group. So these are the four variables that I need to populate. So let's copy this. And let's paste it here. And let's click on add. And here I have added the other task as well. So this particular task, it will just run the Azure CLI to create a container. And one more thing is the four variables, the resource group, the login server, the username and the password I have stored in this particular variable. I need to store in this particular variable. So let's click on new variables and let's store all those values. So let's just collect all those values before I do that. So let's add these values one by one. So I'll just copy this, click on variables, new variable, and the resource group would be containers. So let's just copy this, paste it here. Okay. And similarly, let's add the other ones as well. Copy, paste. This is the username. Okay. And finally the password. So I'll just copy this. Click on OK. And let's click on save. Okay, so we are all set now. So now what this particular task will do is it will first build this particular image, and then it'll call this particular Azure CLI script to create a container instance. So let's save it and run this. So now this particular pipeline will also get saved in the Git repository as well. So I will share that particular Git repository in the description below. So you can just go have a look at that. So let's click on save, and let's run this particular workflow. So this should create a new workflow, and let's just wait for this to complete. Okay, so our pipeline has finished and it just took around 2.5 minutes to run this. So let's go back to our application and let's look at a container instance and let's see whether an application has been created. And if you go to the container instance, you can see that this particular container got created. And this was the same container that we had created in our pipeline. So let's open a URL and let's see whether it works. And you can see that there is a hello world. So the final thing that we'll do is we'll update some change in our GitHub, and that should automatically trigger the build. So let's go back to our GitHub. So let's click on the server.js and let's edit this particular file. So let's just call this as hello world version 1 and let's save this. And let's go back to our pipeline and let's refresh this. And you can see that there's a new trigger that got created, and you can see that there is a new build that is getting created. So this particular new build will update the code. So let's wait for this to finish as well. So if I go to the build, you can see that the processes that are running currently. And if you go back to the GitHub repository, you can see that there is a Azure pipeline.yaml file. So if you have any issues, you can just refer to this particular YAML file. And this YAML file has all the tasks that is mentioned in the pipeline. So this particular link to the repository I'll give in the description below. So you can just go check it out. So let's wait for this particular process to finish. Okay, so our build has finished, and if you go back to the URL, you can see that it has been updated and it's Hello World version 1. That is the text that we had added in the Git is present here as well. So that is how you can create a CI/CD pipeline using your Azure pipelines. I hope this was useful. I will see you in the next chapter. Now, apart from your container instance, you can also deploy containers in your app service. So let's see how we can do that. Now, app service is a topic that I had discussed in my previous section. The link to that particular section I'll give in the description below, so you can just check that out. So let's create an app service and let's create it in a resource group. So I will create a new resource group. Okay. And here I need to give a name for my app service. Now here you have the option of either deploying your code directly or you're deploying your Docker container. So here we need to choose a Docker container and we need to choose Linux, or you can also choose Windows. So let's choose Linux for this particular example. And let's create our web app. And once we've created this web app, into this web app, we'll deploy our containers. Let's click on review and create. You can do it directly here as well, but let me explain to you after I've created my web application. Click on create. Okay, so it has been deployed. So let's click on go to resource. And here what you need to do is, the first thing we'll do is we'll click on this URL and see what we get here. So if I copy this and if I paste it in my browser, you can see that you get a default page. So what we need to do is we need to go back to our console, and here we have to go to a container, deployment container. And here you have the option of either deploying it through a container, a GitHub, or Azure pipeline. So what we need to choose here is the container registry. So the first thing you can choose, and here you can either choose single container or Docker Compose. So if you want to just have one container in your Azure App Service, then you choose this. Or you can also choose Docker Compose if you want to have multiple containers in your app service. So for this example, let's choose single container. And here you have the option of either deploying it from your Azure Container Registry, your Docker, or any other private registry. So we've already gone through all of this before. So let's choose the Docker Hub and let's make it a public repository. And all that I'll do is I will just deploy the latest Nginx server that is available. And that's it. So let's just save this and let's refresh our page now. Okay, once you've deployed the Nginx directly, so let's also deploy something else. So here what I'll do is I go to my public, instead of public, I'll go to my private repository and let me log into my private repository. And I will use a private repository. The private repository that I have created, I'll be using this to deploy my application. So let's copy this. I'll just copy this and let's check out the tags for this. And the tag here is latest. So I'll be using the latest tag to deploy this. So let's go back to our Docker console. And here all that I need to do is I just need to copy that. And now let's save this and let's see whether our container gets updated. Okay, so we've deployed our application. So let's refresh this page and let's see whether it gets updated. And you can see that it's pointing to the hello world. So it's pointing to the node application that we've created. So that's it for this lecture. I will see you in the next. Okay, so one advantage of using your app service is that there is continuous deployment that is already inbuilt for you. So all that you need to do is you need to go to your deployment center. And so currently I'm using a single container that is connected to my Docker Hub private account, and it's reading from this particular image. So what I need to do is I just need to enable my continuous deployment, and I get this webhook URL. I just need to copy this and I need to go to my Docker Hub account. So here I'm in my Docker Hub account and I'm in that same repository that is connected to my application. So all that I need to go do is I need to go to my webhooks and I just need to create a webhook and just need to paste that particular value and click on create. And once I have done this, let's go back to our application. Let's make a few changes. Okay, so I'm in my application right now. So let's add something in my application. So hello world, this is version 1 of my application. So let's build this particular application now and let's deploy it. So let's clear the screen. So I'll just do a Docker build. I will use the same tag, and this goes to the latest. And let's build this application. So let's clear the screen. Let's do a Docker image ls. So this is my application. I just need to tag it to my private repository. So let's do that. So let's do a Docker tag. This is my source image and this is my destination. and let's put the tag as well, and let's tag this application. And finally, let's do a Docker push, and let's push this to our repository. And now when this particular push is done, it will automatically trigger a new build in our app service. So let's wait for that to happen. Okay, so this is done. So let's go back to our GitHub account now. And let's go to our webhook and let's see if there's any history now. And you can see that one webhook was triggered. So all that we need to do now is we can just go to our deployment center again, and let's go and check the logs, and let's refresh this. And you can see that there is a new pull that is happening. Okay, so now if you check the application, you can see the changes are reflected in this particular URL. So that is how you can do continuous integration with your registry. So I hope this was useful. I will see you in the next. Okay, so in this particular chapter, we'll use the Azure pipeline to create our CI/CD. So the first thing that we'll do is we'll connect our GitHub to our Azure Container Registry using Azure pipeline. And once we've done that, we will use that image that we've stored in our container registry to push it into our app service. And this too shall be done using Azure pipeline. So let's see how we can do this. So let's go back to our console. And here what you need to do is you need to use the Azure pipeline, but we'll not be using it directly in app service. What we'll do is we'll go to our dev.azure.com and we'll create it from there. Okay, so I'm in my dev.azure.com. I've created a new project, and within this, let's create a new pipeline. So let's click on pipeline and let's click on new pipeline here. Okay, but before I do that, let me show you the GitHub repo from where I'm going to pull the code. So let's go to our GitHub account and let's go to our repo. And here I'll be using this container CI/CD. And this is the container that we'll be using. And this particular container just has a package.json, a server.js, and a Docker file. So we'll be using this repository to connect to our container registry via pipeline. So let's go back to our new pipeline. So the first thing you need to do is you need to connect your GitHub. So let's click on GitHub and let's choose the repository. So what I need to choose is this container CI/CD. So this is that particular repo. So click on that. And I need to push my code into my Azure Container Registry. So let's click on this. And let's open a subscription. So here you need to log in again. And you can choose the container registry. So I have one container registry and I'll be using this. And here you can give a name for your particular repository. So let's just call this as my Express app. And this would be the name of my repository. And this is the name of my registry within which this particular repository resides. So let's click on validate and configure. And let's save and run this. So when I click on save and run, what is going to happen is that, so when I click on save and run, this particular first part of our pipeline will be complete. That is, the GitHub would push the code to my container registry and it will build an image out of that particular code. So let's click on save and run and save and run. And if you go back to your repository, you can see that there's a file that will get generated, and this file has got all the commands that is needed. So you can see that there's a file called Azure pipeline.yaml file that gets created, and this has all the configuration that is needed. So let's wait for this particular build to finish. Okay, so the build is done. So let's go back to our repository. So let's click on our container registry, and there should be a new repository that gets created. So let's open this and click on repositories here. And you can see that this Express app repository gets created. So let's open this And you can see that there is one image present in our container registry. So once this is done, let's do the second part of our configuration, that is connect our Azure Connect container registry to our app service. So let's go back to our CI/CD pipeline again. And what I need to do is I need to edit my current pipeline. I'll click on edit, and I need to choose the appropriate task. So the task that I need to choose is Azure Web App for Containers. Let's open this. And here again, let's choose a subscription. So let's create a new subscription. Click on authorize. Then you can choose your app name. And here, let's deploy this. And you can just give a app service resource name and it'll be in production. And this is the important thing, that is you need to give the image name. So let's go back to our repository once again. So you can go to your access keys first. And you need to copy the login server. So let's copy this, paste it here, slash, and you need to give the name of your repo now. So this is my repo name, paste it here. And you also need to give the build ID, which represents our tag. So I'll just copy this variable and I'll just paste it here. And that's about it. So let's add this particular task here. Okay, so we just need to reformat this. Okay, now it's properly formatted. So let's just save this, save, and let's run this once. Click on run. And you need to authorize this as well. So let's click on view and permit here. Okay, so this is completely low. Let's go back to our app service once more. Click on this. And let's click on our URL. And you can see that there's Hello World version 1. So the next thing that we'll do is we'll make some changes to our code. So let's go back to our code here. Click on server.js. I'll edit this. And let's make this version 2. And let's save this. And this should automatically trigger a run. So let's go back to our pipeline once. And you can see that there's a new build that is happening. So let's wait for this particular build to be over. Okay, so our build has succeeded. Let's go back to our URL. And you can see that it has changed to version 2. So that is how you can use your pipeline to create a CI/CD. So I hope this was useful. I will see you in the next chapter.